Now, coming to the last part of the chemical explosives. Now, in this part, what we will learn some preparation of properties of some common explosives. We will not cover this preparation and properties of every explosive. We cannot cover that because there is a wide range of different kind of explosives. So we will just try to figure out some
good examples or some important examples of chemical explosives. The first one is the RDX. Now, what is RDX? As you have already come to know that the full form is RDX is Research Development Explosives. So this is the chemical formula. This is the structure of that RDX, and the chemical name is, or the IUPAC name can be written as that. This is the position 1, then this will be position 3, then this will be position 5. So 1 3 5 trinitro per hydro, 135 trinitro per hydro, 135 triazine, 135 triazine. So 135 trinitro per hydro, 135 triazine. So RDX is basically a white solid. It doesn't have any kind of taste, it doesn't have any kind of smell, and it can be stored easily for several years. Okay, so now how we can prepare this RDX? So there are several methods. First, we will look out in this Helles method. In this Helles method, now RDX can be prepared by the destructive nitration of these hexamethyl tetramine with concentrated nitric acid. Upon the reaction, what we will get? We will get RDX along with ammonium nitrate and formaldehyde. So this is the Helles method. So this is the destructive nitration of hexamethyl tetramine with concentrated nitric acid to get RDX. Now, this is the second preparation of RDX. This preparation is named as Abel-Sizzler-Rose method. Through this method, RDX can be prepared by addition of formaldehyde and ammonium nitrate to acetic anhydride at 70 degrees centigrade to get RDX along with acetic acid. Okay, so this is the Abel-Sizzler-Rose method to get RDX from formaldehyde and ammonium nitrate reacting with acetic anhydride at 70 degrees centigrade. So this is the third method of preparation of RDX. What is this method called? This is named as Batchman method. Under this method, RDX can be prepared by using this hexamethyl tetramine with ammonium nitrate and nitric acid to acetic anhydride. So it can be obtained by mixing hexamethyl tetramine and ammonium nitrate and nitric acid to acetic anhydride. So we will get RDX along with acetic acid. So this is the fourth one and the last method of preparation of RDX. It is named as Wolfram method. This method involves actually two steps. This is the first step, this is the second step. In the first step, what is happening? In the first step, potassium amido disulfate, potassium amido sulfate will react with formaldehyde to give potassium methylene amido sulfate. So basically the conversion of potassium amido sulfate to potassium methylene amido sulfate. In the second step, what will happen? These potassium methylene amido sulfate will react with nitric acid, that is basically the nitration of these potassium methylene amido sulfate, and what it will give? It will produce RDX. So basically these potassium methylene amido sulfate will react with nitric acid under H2SO4 medium to give RDX. Okay, so this is the overall preparation of RDX. We have already learned that is 4 methods. Okay, first one was the Helles method, second one was the Abel-Sizzler method, third one was the Batchman method, and the fourth one was the Wolfman method. Okay, so now we will look into the important properties of RDX. So this will be the RDX preparation. Now we will look into the important properties of RDX. So these are the important properties of RDX. See that when we classified that explosives based on the sensitivity, we have already come to know there were primary, secondary and tertiary explosives, and there we have come to know that RDX is a secondary explosive because it is having less sensitivity. As it is having less sensitivity, so therefore it can only be detonated by the detonator. It cannot explode. It cannot explode without any kind of help of detonator. It can only explode with the help of detonator. And it is also stable at room temperature. It is a stable explosive, and it will actually burn rather than explodes at room temperature. And it will actually start decomposing above 170 degrees centigrade temperature. Below that temperature, it will not decompose. Only above 170 degrees centigrade temperature, it will start decomposing. So there are three important properties: that it will detonate only with a detonator. It is very much stable at room temperature, so it is a stable explosive. It will burn rather than explodes, and then it will start decomposing above 170 degrees centigrade temperature. So this is the overall preparation and properties of RDX. So this is our second explosive, that is lead azide. So now we will discuss some important preparation and properties of this explosive, that is lead azide. Now what is lead azide? Lead azide is actually a white crystalline solid, and it is basically considered as a primary explosive. Now based on the sensitivity, we have classified the explosive in three categories, that is primary, secondary and tertiary. And now lead azide can be considered as primary explosive. So primary explosive means that it can be used as a detonator, or you can say that it can be used to trigger the secondary explosive. Lead azide was first prepared by the scientist Curtius in the year of 1891, and later it was commercialized in the year 1930, and it was extensively used as an explosive during the World War II. This its structure, that in the central actually these lead cation or lead plus 2 ions is there, and at the both side two Hite ions, that is N3 minus ions are there. Okay, so this is the overall structure of lead azide. Now coming to the preparation. Now lead azide can be prepared by treating or by reacting the sodium azide with lead acetate, or by reacting sodium azide with lead nitrate. Now then, before this preparation, you have to get the sodium azide, right? So how will you prepare the sodium azide? Sodium azide can be easily prepared by reacting sodium amide with nitrous oxide. So when you are reacting sodium azide with nitrous oxide, you will get sodium azide. Then sodium azide should be treated either with lead acetate or with lead nitrate to get the desired lead azide. Okay, so this is the overall preparation. This is comparatively easier. Now coming to the properties. Now lead azide is actually white crystalline solid at room temperature. It generally melts at 190 degrees centigrade, but it is comparatively stable, and then explodes at 350 degrees centigrade. It melts at 190 degrees centigrade, but still it is stable, but explodes at 350 degrees centigrade. Now coming to the third point, we should comment regarding the solubility in water. It is partially soluble in water at room temperature, but when you will increase the temperature, then solubility will be increased. Now, it is fairly soluble in acetic acid, that is very well soluble in acetic acid, but it is actually insoluble in liquid ammonia. So, solubility in acetic acid means it is very well soluble in acetic acid, but it is actually insoluble in liquid ammonia. Coming to the fifth point. Now, when lead nitrate explodes, what you will get? When lead nitrate explodes, it will mainly generate lead along with nitrogen and heat. So, huge volume of nitrogen gas will be produced. It is actually not hygroscopic in nature. Not hygroscopic means that from moisture it will not from air it will not absorb any kind of moisture. So therefore its sensitivity cannot be reduced. Its sensitivity will be intact, because it is not hygroscopic in nature. Now coming to the point, its explosive characteristics. Actually, it is highly sensitive. As it is highly sensitive, it cannot be stored like the other explosives. It should be stored underwater in an insulated rubber container, so that it can be handled easily. Now, how it explodes? It can explode only after the fall of around 150 millimeter or in presence of 7 million joules. So it can or it should explode with the help of either of these two conditions. Either it should fall of around 150 millimeter or in presence of 7 million joules. Its detonation velocity is almost 5 kilometer per second. That is huge. Its detonation velocity is almost 5 kilometer per second. And what is this DDT? DDT means that it has immediate deflagration to detonation transition, which means that even a small amount of it detonates in presence of flame or static electricity. So this is the overall lead azide, its preparation and properties. You will get the study material regarding this under the description box, and if you are unable to find that, just follow the Telegram link given in the description box, message through that, we'll try to provide you directly. Now, this is our third explosive, or you can say that this is the last explosive we will discuss, and we'll discuss the preparation properties of this explosive. That is PETN, that is pentaerythritol tetranitrate. P for penta, E for erythritol, then TN means that tetranitrate. Now, this PETN is actually a high explosive organic compound. Okay, and chemically, actually, it is the nitrate of pentaerythritol, and structurally it is very much similar to nitroglycerin. Actually, this penta, the term penta refers to the 5 carbon atom of this neopeptide skeleton. What is neopeptide skeleton? So this is basically the neopeptide skeleton. It is almost similar to the skeleton of these PETN. So these are neopeptide skeleton. So penta refers to the carbon atom, 5 carbon atoms of this neopeptide skeleton. 1, 2, 3, 4 and 5 carbon atoms are there. Okay. So the molecular formula, you can say that C5, H8, N4 and O12. See, this is the total chemical formula. This is the chemical formula or molecular formula of PETA. So, and the structure is like this, that neopeptide unit is, or neopeptide skeleton is at the center, and then 4 ONO2 groups are at the 4 sides. And it can be named as corpent or ten or penthrite also. Now, coming to the preparation of this PETN. Now, PETN or this pentaerythritol tetranitrate can be prepared like this. So, first, this pentaerythritol should be added or should be reacted with this nitrating mixture, that is concentrated H2SO4 and HNO3, that is nitric acid. So when you will react these two reagents, you will get that these PETN. This PETN will be first precipitated out and then it will be recrystallized. So this is how we will get this PETN, or you can prepare this PETN. So now on next we will discuss about the property. So these are the important properties of PETN. So it is actually white crystalline solid at room temperature, and it is comparatively highly sensitive to the action of heat, pressure, friction, etc. It is basically insoluble in water but weakly soluble in non-polar solvents like aliphatic hydrocarbons and some in acetone. Its toxicity is comparatively low, and it actually undergoes bacterial biodegradation slowly. It is having comparatively less volatility. Because of this less volatility, the sniffing dogs cannot smell it and it cannot be detected. For example, you just think that this PETN is placed somewhere. As it is having less volatility, so the sniffing dogs cannot get the smell of this, and therefore it cannot be detected. Now coming to the explosive characteristics. It is actually very high, it is having actually very high explosive energy. Now, 1 kg of this PETN can give almost 5,800 kilojoule energy. So, 1 kg of this PETN can generate 5,800 kilojoule of energy. Its detonation velocity is nearly 8 kilometer per second. Its explosion temperature is at around 4,230 degrees centigrade, and its oxygen balance is negative, that is minus 10.1. I have already told you that this, with the negative oxygen balance, the an explosive can have a good explosive characteristics also, and you have already come to know that. Now, this I have pointed out before also, that most of the explosives are having positive oxygen balance, but actually it is not mandatory or it is not essential. With the negative oxygen balance also, an explosive can have good explosive characteristics. Now, coming to the usages of PETN. It is actually a very high explosive with high brisance. High brisance means Brisance means actually shattering capacity. So it is actually having very high shattering capacity. It is an organic explosive with very high shattering capacity. Now it is used or generally used for exploding bridge wire detonators for atomic bombs. Now, if this kind of PETN or this explosive is used, then the usage of primary explosive or detonators is not required. So to avoid the need of the primary explosive, we can use this PETN. Now we will go to this medicinal use. It has some kind of medicinal use, like this nitroglycerin or other nitrates. It has some kind of this medicinal use. It can be used as a vasodilator for the treatment of heart, or you can say that for the treatment of heart conditions. The working principle is like that. It will release a signaling gas, that is nitric oxide, in the body, and this medicine, that is lentonitrate. Some of you are familiar with this medicine, that is lentonitrate. It is nearly pure PETN, which is actually used for the heart conditions. Okay, so now we have already discussed this PETN, its preparation and properties, and we have already noted down three important explosives, that is RDX. That was the first one. Second one was lead azide, and third one is now PETN. So we have discussed these three explosives, their preparations and properties, and their usages also. So this was our third part of these chemical explosives, and you will get the study material link in the description box. And if you're unable to find that, just message to through the message to the telegram link given in the description box. We'll try to give you the study material details. So thank you for watching this video, and please like and share this video as much as possible. Please subscribe our channel. See you in the next class. Bye bye.